So, hello everyone. Hope you all can hear me.
Yes, sir.
Right. So, good morning or good evening to all. All right. So, shall we continue with the next topic in the module, Ansible module? So, how was your weekend? Did you get a chance to practice or like what's the progress? Guys. So, in our last session, we have discussed about the um, playbooks, right? Like how we can use our playbooks to prepare or manage your modules, execute your modules in target machine using variables, how you can able to parameterize, and also using your conditions, how we can able to ensure that the playbook are getting executed in exact node based upon the Linux distribution, right? So what else? Okay, so we'll be talking about the Ansible variables and handlers and roles now. Okay, handlers and Ansible roles using Galaxy. Okay, so when we talk about the Ansible handlers, right? Handlers also, it's a kind of a task. Like if you can recollect our last day session, we have written some task definitions, right? Like, so if you can look into this playbook here, we have written this playbook with some number of tasks, like we were able to execute this particular task. So when you create any playbook, it is used to actually execute some modules. So the collection of modules you can able to consider the task. So any module you execute, it will be having its own name and also the arguments that is going to identify the input properties or parameters of that module. And this task is going to directly define the module. What is the name of the module? What is the parameters, everything you can execute, you can define here. And as soon as you execute this playbook, what all the modules you define within the task will get executed in a sequential manner. Got it? Consider a scenario. I want to execute a playbook with 3 different tasks. But the execution of current task is depends upon the execution of previous task. Say for an example, you guys are aware of your Tomcat server configuration, right? Yes, no?
Yes.
So if you want to set up a Tomcat server, what are all the prerequisites there?
JDK.
Okay, then okay. Maven, huh? Who's that? Why you need Maven for a Tomcat server? Yeah. What is the logic here? What is the need for Maven here to set up Tomcat server? Tell me what all the things. Okay, not just forget about Tomcat. if I want to install any package, what are all the things I should consider?
First of all, package manager.
Okay.
You have to download the Tomcat.
Sorry.
Download the war.
Can you please repeat the question once again?
So consider I want to set up a Tomcat server. Not only Tomcat server, even any package you install, first you need to take care of all the prerequisites, right? And then you'll install the actual tool and then configure the tool, that is a post build actions or post installation process. That is what we did in a Jenkins also. Like if initially when you talk about Jenkins, you install JDK and then install Jenkins and then started Jenkins service. Similarly, Tomcat, install JDK and then install Tomcat and then start a Tomcat service. Like this, I want to set up a Tomcat server means I need to perform these three activities. And all these three activities should be in a sequential manner, right? So the execution of second step, it is depends upon the first step. Similarly, the execution of third step depends upon the previous two steps. Correct. This is what the sequential execution of your playbook. And here, the process, whatever we are going to have, it depends upon each other. Correct. So if I directly write a playbook and execute this particular playbook, assume that there is a playbook I have written, and in that playbook, I just created these three steps. So using apt package manager, I can install JDK and then Tomcat and then starting the Tomcat service. If I submit this playbook for execution, assume that your Tomcat, JDK installation is successful, but due to some reason, Tomcat installation is getting failed. What about this third stage or third task, whether it will execute or not? By default, it will execute. Ansible will execute this step and it will fail that step. Correct, because the flow of execution, what are the tasks we define, all the tasks will be executed by your Ansible. But here it is logically depends upon the previous step. So whenever the execution of current step, if it is depends upon the execution of a previous step, how you can able to control the flow of execution? For that only we use a concept called handlers. Handlers are used to control the flow of execution of the task. So I'll show you how to work with Ansible, how to create such control flow, everything I'll show you. But before that, did you get chance to practice Ansible? Is anyone installed Ansible and started creating this? Did you get chance to practice or like not it started?
Yes, I have tried.
Yes, creators.
Okay, any questions before we move on to the next topic? It's all clear?
It's clear. So
Yes, yes.
It's clear to all. Wow. Awesome, yeah. Fine. So if that is clear, then you can consider this one. So as I said, handlers are used to control the flow of your playbook execution based upon the execution of a previous task. And how you can able to control the flow of execution means by introducing some notified task. So consider I want to execute this particular task, start Tomcat. Only if I notify, the task will get executed. Otherwise, it won't. So what are all the tasks that you want to execute based upon the notification? You define the task under the handlers. Because handlers also, it is same as like your task. Got it? Handler is also the same as like your task. But only difference is the task, whatever you define within the handlers, it get executed only if we notify. Got it? Just a second. Let me log into my AWS console. So where is it? So how many servers or how many work Ansible nodes you had there in your architecture? Same as 2 or like what?
One controller, two worker node.
Hmm. Okay. Mm, okay. So let's get into the DevOps admin user profile and go get into that directory like Ansible playbook, right? So we have prepared some playbooks on the day to handle your variables and managing packages, right? So if you consider any playbook, a playbook composed of various tasks to execute some modules. So if you simply submit the playbook, what are all the tasks you define in the playbook will get executed in a sequential manner. So while managing a packages, it is completely responsible to maintain the sequence of execution. Which tool should get installed first? Which one should be next? So it is completely our responsibility. Correct. So just look into this particular playbook. Here, I'm going to create a playbook and run it on sample node 1. I don't want to collect, or I mean, I want to execute this as a root user. So I just elevate the access root level. And here I have the very first task name, that is to install Nginx. Nginx is one of the web application servers. So if you want to install the task like Tomcat, if you want, you can use Tomcat also. But Tomcat uses some other process. So identify the package by using the name of the package, and then use a state key to identify the state of action, whether you want to install, uninstall, or upgrade. So if you say present, Ansible will get into this node. If Nginx is already present, it won't do any action. If Nginx is not present, then only it will go ahead and install Nginx. Once this step is completed, once this task is completed, the control will automatically come to this task. And here, this task is to start Nginx service. As like how we start our Jenkins or Tomcat, we can use this task to start Nginx service. So to start, stop, or restart, I repeat, to start, stop, or restart any task or any service, we use a service module. So as like your yum module or apt module or shell module, we have a service module in Ansible that is used to start, stop, or restart any service. So this service module has two parameters. One is the name parameter, that is to identify the service that you want to start, and the state parameter that is used to identify the state of action, whether you want to start, stop, or restart. So here also we never directly give a command to start anything here. We never say start Nginx. We use a term called started. So what I'm trying to say here, Ansible should ensure that this task is started, it is up and running. If the service is already up and running, it won't do any action there. If it is in stop state, then we will go ahead and start. Similarly, you stopped as well as restarted. So if I simply submit this playbook, as per the flow of execution, the first task will get executed and immediately second start will execute. Now, consider I'm running this playbook in my sample node 1. My sample node 1, what it is a Ubuntu machine, correct? Can I use yum package manager in Ubuntu machine?
No.
Not
No.
possible. So this module is not applicable to my node. Either I should use win condition to control this flow, or if I'm not using it, the control will come to this particular task and execute this module, and it will fail this task. Once the task is failed, it won't stop that playbook execution. The control will try to execute this task also, and it will try to execute this command. What if the Nginx is not installed in the machine? This step also it failed, right?
Yes.
So that is how the Ansible, executes your modules one after the other. So in order to overcome this, the step which depends upon the previous step, I should not define it directly under the task definition. I have to define it under the handler task. Handlers also, it is a kind of key. So just look into this scenario here. So earlier, this particular task 1 is having the name of the task, module name, and then the state, right? Which module you want to install. But in addition to that, we have to use one key called notify key. Notify followed by the handler task name. And the task, whatever you define to start your service, including the name, it should be defined under the handlers key. Correct? So handlers and task both are used to execute the Ansible modules. nothing else. See, this is also having the module to execute. This handler is also going to have execute a module. But the point is, the modules, whatever you defined within the handler, this module will get executed only if you notify. If I'm not using this notify key here, then this task will not get executed at any point of time. You see? And what does this notify means? Here, I'm trying to execute this APT module. Once the module is successfully executed, then only Ansible will notify to this particular task. Start Nginx is a task that is defined in your handler. Got it? Are you clear with this? So once you submit this playbook, first it will execute your task 1. If it is successfully executed, then it will check for the notify key. Which task is defined in the notify key, that task will be executed from this handler. Easy. Due to some reason, if there is no changes happened, in the case, it won't notify to this task. It won't start. Like this, we can able to control the flow of execution using your handlers. Easy. And if you want, you can able to manage with when condition also. Like earlier we used when condition, right? That is also possible, but it is not for all the things and we cannot reuse it. Let's say I have this handler task. What is the purpose of this handler task? It is used to start a service, correct? That's all, no? It is just to start a service. So as per the process, I can parameterize this. This task name I can receive at runtime. So what it means? This handler task can be used to start any service, not just Nginx. If we parameterize this name of the task or name of this package, then this handler task can be reused any number of times for any number of services. And in real-time environment, we never hard code these handler tasks as part of your playbook. These handlers, as a best practice, it should be maintained in a separate file or a separate folder. As like how we maintained our variables file. Remember, we talked about the variables file, right?
Yes.
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 So variables files are the common files. It is not meant for one playbook. You define it there in a GitHub repository, and which playbook needs the data, you can use that file in the playbook. Similarly, the handler task, starting the service, stopping the service, or restarting the service can be maintained in a handler, and whenever required in your playbook, you simply notify that one. Easy. So this is about your handler. Very important thing in real-time environment, but there are some best practices. So in Ansible, what is the purpose of playbook? Playbooks are used
Creating
to
the automatic task.
Execute the
execute
series of tasks.
some series of tasks, right? And another important thing is playbooks
Reusable.
should be reusable. Correct. It should be a reusable entity. So please keep these 2 points in mind. So initially when Ansible was introduced, right, we found it very easy because we have a complete control in previous version of Ansible and all. But over the period of time, they have introduced one concept called Ansible roles. Okay. Ansible roles, it is the best practice, one of the best practices. If you want to work in Ansible, let's say I have a team member, infrastructure management team member, and I'm expecting him to create one a database server, like MySQL server database configuration he has to do. So to set up the MySQL server database, what are things required? He has to create a playbook out of for that. And as like that, we never allow any users to create a playbook in real-time environment. So what we usually recommend is like whenever the user wants to create a playbook or any components related to the playbook, they're not supposed to directly create. Instead, they have to refer their existing source code repository, because in that source code repository, we maintain all the Ansible related components. Okay, so how we can maintain all those Ansible components means by using Ansible roles. So basically the Ansible roles are used to organize Ansible components. Ansible component means it can be a variable, can be a handler, or any default values, right? Or any parameters. All these components should be organized. Even if you noticed, how many of you noticed actually, like when I created a variable file, where I created actually, I have
In
created a
host.
separate folder, correct? In this machine, I have prepared a separate folder for my variables. Similarly, I create a separate folder for my playbooks. Instead of creating the variable folder, I can able to create the file here itself, right? Why I maintain in the folder? This file, even if I create it in my default directory, it will work, right? But why we created one folder and maintain that file here? Similarly, the playbooks. I have created these many playbooks. Why I create a folder to maintain these playbooks? So this is what the process of organizing your Ansible components. Okay, your Ansible roles is used to automatically organize the Ansible components. So in real-time environment, you never create a folder like playbook or variables or handlers and all. Using Ansible roles, we can able to automatically create those folder structures, because the naming convention is very much important. If I allow the user to create a folder for variable, the variable folder, if they maintain a case sensitive content, or if they use capital V, or each and every one will be having their own, way of creating a folder, right? So that should not be there. There should be some uniformity in maintaining Ansible components. So such things will be generated with the help of your Ansible roles. So it is used to automatically organize Ansible components. Second point is, it is used to reuse. Okay, it is used to reuse the Ansible components. Like if I maintain the components in a separate folder, let's say I have this variable file, I can able to refer this file in any playbook, right? Correct. Similarly, if I have a handler in one folder, I can able to refer that handler in any folder. That's what the reusability. It is used to reuse the Ansible components. And another important thing is it is used to share the Ansible components. Definitions. So I'll show you how to work on it. Okay, listen carefully. But for all these things, you need to be very clear about what you're going to do, your task. The main thing is the objective. So I already talked about it. Whenever you want to go with any sort of configuration management, you have to take care of three important things. One is to take care of the prerequisites. Second is to install the required packages, actual packages, and then do the post-installation activities. So just look into this scenario here. Listen carefully. Consider I want to set up my SQL database server. So first we have to install all the prerequisites for MySQL database server, and then we'll install the package, and then we'll do some post installation activity. Like we have to start the database service. And after starting database service, we have to create database. So only if you create database, developers can able to use the database to create the tables. So as an administrator, your task is to fulfill all the requirements. If you get a requirement to install SQL server, you should not focus only on this particular point. Correct. As an administrator, we have to consider the prerequisites and also the post installation activities. It is not about just starting the SQL server. Developers, they have to create a table, right? So they should have a database. So it has to be done. So how you can able to define in this playbook means, consider I have a playbook here. This is the name of the play. Name of the play is to install and configure MySQL. And the host, that is DB server. DB server means it can be an independent server name or it can be a group name that is defined in my inventory file. And the task. What is the first task? It is to install the prerequisite. So I'm going to use yum module and the name of the package which I want to install along with the state parameter. So yum module will identify this package and depends upon the state, it just installs it. And the next task is to install MySQL package. Here also we're going to use yum module and the name of the package MySQL, state is present. Now, once MySQL server is installed, we have to start that service. MySQL server database has to be started. So use another task to start MySQL service, and the service name is MySQL state is started. Similarly, once the service is up and running, you have to configure your database. MySQL DB is one module actually. It is Ansible module used to manage your database. So when you use MySQL underscore DB, name as database name which you want to create, and the state is present. Correct. Like this, we can able to define all these things in your Ansible playbook. Can you able to understand the playbook definition here? What we are trying to do? Can you able to understand?
Yeah,
All of you. Hope it's clear, right? Whatever we are doing here is clear, no? Consider I have prepared this playbook and I have executed it and it is working as expected. Down the line, after a month or two, there'll be some other team. They might need to configure their MySQL database server. So for that team, can I go and create one more playbook? Can I create another playbook for the team? Even the same team might come down the line after a month or two to create one more database server, right? So can I create one more playbook for the team to set up this?
We can reuse it.
That is the point. Okay, so as per the process of Ansible, we are not supposed to create the playbook for any specific team or a process. Once you create a playbook, you have to preserve it and it should be reusable. Correct. So preserving means you have to organize the components of Ansible in a proper manner. So how it is possible means by using your Ansible roles. So just look into the scenario here. In my playbook, I have a task definition. I have 4 tasks actually. So what I can do means, as per the process, I can create a role and the role name is MySQL role. Within the role, I'll be having one subfolder for task definition. And that subfolder can have all these task definitions. And it will be stored or saved as separate folder in my local machine, or it can be in my GitHub. Correct. Now, whenever you want to create MySQL database server using a playbook, just create a playbook template. This is just a template actually, name of the play and in which server you want to execute. But the actual task definition will be populated from the role. We use a key called roles followed by the name of the role. So name of the role is MySQL. So when you use role followed by that role name, what are all the folders and the components you define in that folder, it get populated to a playbook for execution. So this way, your playbook will not have any constant values for your process. And Ansible roles are not just to manage your task. Using Ansible roles, you can able to organize any type of Ansible components. Like it can be your task folder or variables, handlers, defaults, or templates. So organizing Ansible components is what Ansible role. So this can be my root folder, and within the folder, I have some subfolders. Correct. So once you prepare this, you can able to give all your definitions related to the MySQL Server database. This role is meant for MySQL Server. You can have your task definitions, you can have your database credentials and some default values, handle task, templates, everything, and save it as one folder in your local machine. And if you want to share it with others, you can simply publish it into the container source code repository. Got it? So that is what here we call it as sharing. First, we will organize your Ansible components in the form of folders and subfolders, which is probably used to reuse your Ansible components. And using a GitHub repository, you can able to share this entire folder. So if you look into this folder here, MySQL is a folder name, root folder. Within that, it will be having some subfolders for task definitions, handlers, variables, defaults, everything. Tomorrow, what I can do, I can simply push these changes to my source code repository. Got it? So how to create such folder structure means no need to create it manually, okay? Because Ansible roles are used to automatically create your or organize Ansible components, right? So there is a command called Ansible-galaxy init command. Using this command, you can able to initialize your Ansible role. You see? So once this is initialized, then you can able to define it for task definitions, handlers, where you can define it, and then you can save it as a folder. And if you want, you can share it with other users also through your source code repository. So this is how the process actually, like, not sure how many of you observed when we installed Ansible, there is a folder called roles folder, right? Have you noticed? We got Ansible config file. We got the default host file for inventory. And also there is a folder called roles folder created. Have you noticed?
Yes.
So that is used to organize Ansible components basically. Correct. So roles is a default folder for your Ansible role. So plan here is I will create Ansible role now. And once Ansible role is created, then I will demonstrate how to organize, reuse, and then share the Ansible components. And we talked about the handlers, right? Handlers, I haven't showed you any demo actually. I just explained you what this handlers is all about. So we'll be working with Ansible along with this Ansible role, so that will be more relevant. Because in real-time environment, we never define the handler task in the same playbook. It will be organized in a separate folder. Easy? Hope you all clear, right? Listening to this, no? Can you able to understand or any confusions here?
So for different packages, we will create different folders. For if NGINX, we will create
Yeah, each and every configuration management will be having its own role folder.
one time we need to create. After that, it can be reused.
Reuse it. Yes, reuse it.
Yes.
So here I have a folder called roles folder. It is empty now. So what I'm going to do here is I can simply say Ansible Galaxy. Got it? Ansible Galaxy. So you are going to create Ansible role using Ansible Galaxy actually. Got it? So it is a kind of a plugin or extension to your Ansible through which you can able to prepare or create your Ansible roles. Okay. So once Ansible role is created, you can able to reuse it. So let me create one Ansible Galaxy init followed by the role name. Let it be like test role 1, for example. Ansible Galaxy init test role 1. See, one new role has been created. Test role 1 has been created. And if I say ls, I can see one new folder is available. So this is a folder. And within the folder, I can able to see some subfolders. All these things we never created manually. Okay, it's all created with just one single command. But initial days, we were supposed to create all these things manually. We recommend the people to create a root folder and maintain subfolders for each and every components. But now everything is simplified with this utility. And here you can see there's a folder called VARS folder. This is something used to manage your variables. Got it? Don't use any other notations because as per the coding standards, we have to strictly follow some naming conventions. So handlers, defaults, files, tasks, VARS, like that you should maintain some naming convention. So if you are not able to follow this, simply use your Galaxy command as well as in command to create this folder. Now, if you get into each and every folder here, let's say if I go to my task folder here, I can see there is one YAML file, main.yaml. It is just a template. So every folder will be having its own main.yaml file. See, it is just a skeleton or a template that gets created for you. What you can do means you can get into that template and customize it to prepare your own role definitions. So now I'll show you one small example. So as part of this demo, we have just created one Ansible role. Ansible-Galaxy init followed by the role name. We just did it now. Now let's get into that folder. I want to go into this task folder. CD to task. And here I have a file called main.yaml file. Just edit this file, vi main.yaml file. Go to insert mode and it is completely your file now. You can able to prepare any task definitions. So this is a task file for your test role 1 and the name of the very first task I'm going to create is install nginx. The same as like a task definition, nothing else. And then apt package manager I'm going to use as a module and name of the module I'm going to install is nginx, state is present, and then notify start nginx. So what is the purpose of notify here? What is the purpose of notify? So as part of this task execution, once the task is successfully executed, it has to notify this task that is defined in your handler. So the start-nginx is a handler task. Just save this file. Now, since we are given the notify tag, we have to create a handler task. So there is a folder called handlers. CD to that folder. And here you have a same, what do you call that? Main.yaml, edit that file. go to insert mode, and you can able to give that handlers task definition. So here the name of the task handler task is start Nginx. Service, I'm going to start as Nginx, and the state is started. Save this file. Like this, we can able to keep on updating our roles. Like what are all the folders you have, what are all the components you want to update, even your variables, defaults or templates, whatever you want, just maintain it. And once you are done with the definition, you can able to invoke it in your playbook. Sorry. So let me come out of this roles folder. I have a separate folder called playbook folder, right? cd to playbook folder, and here I can say like vi roles demo.yaml. Go to insert mode and have this here. So what I'm trying to here, I have a playbook that is going to get executed in sample node 1. As a root user, I want to execute, and the task definitions, whatever I want to maintain, it should be picked up from this Ansible role. So test role 1 is the role, Ansible role that is defined in your roles folder. So roles followed by the role name. Save this file. That's it. So now this file, it is just a kind of a template or a skeleton, nothing else. If you want to execute, simply say Ansible playbook followed by the file name. Just follow the execution process. It is getting executed in sample node 1 as mentioned in your playbook, and it is collecting the Ansible facts by using setup module internally. And you can see it is trying to execute a task called install nginx. But this task definition is actually picked up from the roles folder. That's what it means. From this roles folder, it is going to identify this task and it gets executed. And as I said, whenever there is any changes happen in that server, then only that handler task will execute it. So it is running the handler task called start nginx that is also present in the same roles folder. Easy. So as a best practice, it is always recommended to maintain a playbook with proper variables, handlers, conditions, and all these things should be defined within a root folder. So that root folder, if you want, you can able to create it manually. If you want, you can create the same root folder structure. There is nothing harm actually. Right? This entire folder, if you want, you can able to create it manually. But when you create it through your manual approach, there might be some typo. There might be some sort of, syntax errors or something might happen. You might miss something. So instead of that, we use a simple concept called Ansible Galaxy. Understood? Hope we can understand the importance, right, of Ansible Galaxy and Ansible roles here. Any question? Guys? What happened? Am I audible? Oh,
Yeah, no questions.
okay. And Ansible Galaxy, it's not like a small deal, okay? Like in a real-time environment at enterprise level, right, we'll be having our own source code repository for configuration management. As like how the developers have their own source code repositories to manage the application source code, we from infrastructure management team will be having our own admin repository. In that admin repository, we'll be maintaining all our components. Got it? So any new user who wants to work on any configuration management, they'll be provided with that repository. And from that, they can able to understand whether you have a repository or everything, and they can able to download and implement it. And another advantage of using Ansible Galaxy, right? It is not just for your limited project level, okay? It is also applicable for your open source projects. It is a huge community actually. So if you can see this page, If you want, I can put in those notes here. Galaxy.ansible.com/UI. If you get into this page, you can see there is a field called roles. Click on the roles and you can able to see there is a huge list of users. Okay. I said, right? Ansible has a huge community support. So there are a lot of global users, right? They will contribute their projects. Let's say today you want to set up your Tomcat server. You have to create a multiple levels of Tomcat server with a lot of JDK and everything, but you're not sure how to write a playbook. So what you can do, you can get into this Ansible Galaxy web interface and you can able to search for the Tomcat like keyword. Tomcat. See, there are a lot of roles created here. It's all available. So you can able to choose, depends upon the tenure, right? Like, see, it's all created 1 year ago. We can't assure that it's all having a relevant configuration. But this is just 4 months ago, this user has uploaded. Just get into this. And this is a command to download in your local machine. And you can find the documentation for that. The user will maintain the documentation for what purpose it is created, how to use this, and how many versions they have, import log, everything. If you want to use this Ansible role in your local machine, there is a command called Ansible-Galaxy role install command. Previously, we used init command. Init command used to create a role in local machine. But if you want to download from your Ansible Galaxy, you can use Ansible-role Galaxy role install followed by the role name. Simply copy this and you can run it here. This is downloading that entire repository. See, as I said, it is picking up from the repository only. They have their own GitHub repository. From there, it is downloading and implementing in my local machine. If you want, you can use your Ansible Galaxy role install command or any Ansible role you see there, right? It will be having its own repository. The GitHub repository, what you're seeing here, no? Can you see this?
Yes.
So if you want, you can able to get into the repository. See, there's a repository they have. Every folder they have actually. It means they must have used Ansible init command to prepare this repository. They have configured it and then they just publish to their remote Git repository. So instead of using this install command, you can directly get into the repository. Then you can able to verify. You can able to go through what are things there. Let's say if I go to task definition, what they have a main.yaml file, package, service. Like this, they have some definitions. So this main.yaml file will be calling other packages or other manifest files like package, service, and then other stuff. Like this, go through your repository. If you really want this, clone, copy the URL and clone it. You know how to clone the repository local machine, right? So use git clone command and clone the repository. You'll be getting that actually. Or you can simply use your download button to download and extract it. Copy the link address, download zip file. You can able to extract it. Simple. Am I clear with this? So
Yes.
even tomorrow, if you want, you can able to log into this Galaxy. Here, you can create a free account. It's a free account, okay? You can create and you can able to contribute. Like for your research or for your practice, if you have created any Ansible playbook and if you want to share it with the global community, you can create account and contribute there also. It's possible. Correct. And most of the vendors, like there are a lot of things related to the monitoring tools. And even we have a lot of AI-based tools and all available there. So if you want to set up any infrastructure with some monitoring and enabled with the AI tools and all right, the service provider will be creating some roles and uploading it here. Correct. Let's say even last week also we were doing some sort of, not last week, almost two weeks earlier. So we got a requirement to set up the Dynatrace monitoring tool. It is enabled with some latest AI monitoring. So it is a vendor support product, okay? Because monitoring Dynatrace is a paid service, and as like that, we cannot get the product code and all. We cannot directly install. Like for example, if you want to install Kubernetes, you have the commands to install, right? But Dynatrace is a licensed product. If you want to install local machine, you have to pay for it, and vendor will be providing you some sort of commands and scripts. That is what you should use. Got it? So what you can do here is just what we did there is like we just connect with the vendor, and they just provide only one small repository. That is your role name. That's all. If we explore that role, it is actually the repository where we can able to see all the task definitions, templates required to set up the Dynatrace and AI plugins on that monitoring server. We just simply run it. There is a playbook also they have provided. Simply run the playbook, it automatically install and configure it. So that is how the vendors will be providing their packages for installation configuration. Even if you want, you can able to prepare your own role. Like consider you already configured your Kubernetes cluster, remember? Open source Kubernetes, you know how to configure, right?
Yes.
You know how to configure open source Kubernetes, right? There are a lot of steps involved. If you
Yes.
want, you can just summarize everything, and you can able to prepare a automation process, and you can create your own role and publish it here. Anyone who wants to use it, they can simply use your playbook to install Kubernetes cluster. Hope you're getting a use case, right? For what purpose I'm talking here. So all the complex configuration management can be simply done by just the execution of a command. Like what are the commands I used here earlier? So as a user, I just run this command, Ansible playbook followed by the roles demo. But this playbook will be invoking a role. That role will be having a number of folders and the components definitions internally. So on user perspective, I just execute this command. All the tools will be available in local machine. That's it. I no need to manually go and search for the configuration parameters or dependencies, everything. Nothing is required. So that is what Ansible is all about, right? It is a configuration management tool, which will help the users to simplify the process. It is a process of abstraction, actually, abstracting all these complex tasks from the view of the users. Easy? Hope you all clear with this, right? What we are discussing here? All of you?
Yes, sir.
So maybe if you are part of infrastructure management team, or if you're responsible to set up some tools configuration in future, this will be a very helpful content, Ansible Galaxy. Just bookmark this page and explore it, okay? Easy. That's it. That's all about your Ansible. So as part of Ansible module, the Ansible architecture and the components, like your inventory, modules, playbooks, ad hoc commands. Okay, ad hoc commands also, it is secondary. It is just for quick configuration or query of the server, but playbook plays a very important role. Correct? So which includes your very important concept called variables, and then handlers, and also there's something related to your conditional execution, when condition. And then the next important thing is your Ansible roles. So these are all the key topics that we use on daily basis. In real-time environment, every people who are working on Ansible process, definitely they'll be using all this on a daily basis, apart from nothing. Understood? Any question? Guys, any question to me?
No, sir.
Is it clear to everyone? Yes, no? And I hope you're all progressing, right? I'm expecting you to complete till Kubernetes. At least, are you working on it? Because only if you can complete, I can able to show you your project demo, like how you can integrate your Docker Kubernetes in your Jenkins pipeline.
Yes, Lok, we are going through each and every module which is saved in the Google,
Eh? Google.
not on the Google, what we call that. One second, let me open
It's
Drive, on
okay.
the
It's
Google
okay.
Drive.
It's okay. It's okay. It's okay. Fine. So on priority, you need to complete your Docker and Kubernetes so that it'll be easy for you to understand the project and the demo which I'm going to provide you. So I'm planning to have this on Friday. Maybe Thursday itself we can start the discussion, but Friday will be having a complete implementation of it. Oh, Thursday, Wednesday you have off, right? So fine. Friday will be having complete demo of your project. Right. So if you're clear with this, then we'll move on to the next module. That is your Terraform. Shall we? Shall we move on to the next module, or do you guys have any question?
Hi, I look right. I have a
Yeah.
question.
Yeah.
So the one you gave some assessment or something, right? So I was going through the recordings. So while deploying the application image in the Kubernetes using pod, I was getting some errors. So I'll share you that screenshot.
What is the error?
It was showing something like 1 minute. Crash loop back off. The status is it's not even running. It was showing like crash loop back off. So
So before executing or trying those assignments, have you created any pods?
yeah, I've created
Have you created replicas of pods using deployment objects?
yes, I have
Uh,
used YAML.
and all those things are running right in your machine?
Yes,
That is the
engine.
point. That is the reason. See,
Mhm.
you are using only T2 micro instance, correct? With 1 GB RAM and 1 CPU.
Yes.
And already that resource is being utilized by your pod as well as the deployment controller object. Like replica set is created, 3 instance of pods already up and running. You must have done some upgrade, downgrade, everything, correct? Scale
Yeah,
up or
right.
scale down. So it's all consuming the resource.
Mm-hmm.
That is the reason it is not having any room for new deployments. That is the reason you're getting it. Please make a note of the error message. Whenever the underlying resource is not sufficient
Okay.
to deploy new pods, you'll be getting the error. Please make note of that error message and the description for this. So in this case, you have two options. One is you just go delete all the pods, delete the deployment objects. I already given you a command to delete, right? Kubectl command.
Yeah.
Use that commands to delete everything. Still, if it is not working as expected, you just go to your AWS console and upgrade your instance from T2 micro to T2 medium.
Okay.
You know how to do that?
Yeah, I know that. But I
Ah.
think so the amount or something it will be
It is a paid, so yeah, T2 my
paid for it.
medium, they will cost you, but it won't cost much actually. Just in few cents, it will be charging like 0.43 cents actually. Okay, it will be like 10 rupees or 15 rupees INR. That's all.
Okay
So
then.
once you complete your task, immediately go and stop the server and change that instance type from T2 medium to, sorry, T3 medium, T2 macro or micro.
Okay.
so that you will be saving your cost. If you keep it as it is like a T3 media means, then you'll be charged for it. Correct.
Yeah, got it. And I got some message like you're,
It
already
is
tapped.
an alert. It is a
Yeah, yeah.
notification.
All.
Your if you consume 85% of your resource, right?
Mm-hmm.
That's what the message you're getting. Eighty-five
Yes,
percentage you
yes.
consume, right?
Right, right.
So it's a monthly alert actually. Monthly, if it is exceeding the 85% limit, you'll be getting that SMS notification. That's not an issue.
Okay. So I deleted some instances because of that. So maybe no, something
Okay,
which
so
will
what
make.
is the error you're getting now? Crash loop.
It's a crash. I'm trying to share with you.
No,
Crash
no.
loop backup.
Just you make a note of it. Okay, you don't need to share the screen. Just make a note of that error
No,
message
I'm sending
and the
to you, but
description.
I'm not able to send to you. So I don't know why. I'm
No, I
sharing.
understood your situation. Okay, that is what
Okay,
the
okay.
error. Even when you say it's a crash loop back off, that is what's issue actually, nothing else.
Understood, understood. Okay.
You got the solution now, right?
Yeah, yeah.
That's it.
Okay. Okay.
And this is for everyone. Okay, whenever you're getting such errors, just make a note of it and try to understand or identify the root cause of the issue. Right?
Looks like, can you give 5 minutes of break, please?
Okay, then carry on, please. Yeah.
And Loksha, you will give the real-time example or something, or like complete for all these topics, right? Like integrating all this thing.
Yeah, we'll have a project demo, right? The last day. That is on
Your
Friday.
voice is low.
See, we'll be having a demo on Friday, correct?
Okay, okay. Oh,
So
yeah.
there I'll take one real-time use case and I'll show you how you can able to integrate your Jenkins, Docker, Kubernetes,
Mm-hmm.
and the build tools to do the process automation, CI/CD pipeline creation. I'll show you.
Okay, okay, okay. Thank you.
Okay, once we done this on Friday, from next week onwards, you can move on to your next module. That is Azure-based thing. We can.
Got it. Okay.
Yeah.
Yeah.
So when we need to upgrade from micro to medium, so we have to stop the instance first. Then we will do
Yeah,
no, right?
that's right. Stop that instances and then update it.
Okay.
All right, so shall we continue with the next topic, guys? Hmm? Yes, no?
Yes. Yes.
Okay. So these Ansible and the upcoming topics like Prometheus, Grafana, it's all like, add just 10, 5 to 10 percentage value to your profile. That is not going to cover your 100%, job opportunity. Okay. So your main objective should be your Jenkins, Docker, Kubernetes. All right. That is meant for your CI/CD. And apart from that, your Ansible, Terraform, and all, it is meant for your infrastructure provisioning and configuration. If you are part of infrastructure management team to support that infrastructure automation, you'll be involved in that thing. Or if you want to automate your process through GitOps, you'll be using that features. Similarly, monitoring. If you're part of a production support or monitoring team, you'll be using monitoring tool. As a DevOps resource, we never create or install any monitoring tools. It is something promptly owned and managed by the monitoring team, actually. Correct. So now we'll talk about the Terraform. So when I start with the Ansible itself, I use the term IAC, right? Infrastructure management. So as part of infrastructure management, we discussed about Ansible, but before you actually manage your infrastructure, you have to provision the infrastructure. So provisioning is actually done by your IAC tools like Terraform, or if you're working on your AWS, you can use your CloudFormation, or Azure means it is Azure RM, that is Azure Resource Manager. Similarly, we have something called Google Resource Manager to manage its resources. Correct. So here, in order to work with Terraform, also, you need to understand the Terraform architecture. What is the purpose of Terraform? What are its capabilities? And we talked about Terraform, I mean Ansible, right? And now the Terraform. So what is the basic difference between Ansible and Terraform? Where you can able to implement it? And also you need to understand the Terraform working principle or process. Correct. How can you use Terraform and implement the changes? What are its working principles or working process? You need to be very clear. Once you're clear with it, then you can able to install Terraform and then create target servers using Terraform. Okay, you can create target servers using Terraform. So installing Terraform, you can able to do it in your local Windows machine itself. As like how you install Git in your local machine, you can use your local Windows machine to install Terraform. That doesn't matter. But another important thing is the script. As like how we talk about Ansible playbook, Terraform also uses some script. It uses the HCL language. That is HashiCorp Declarative Language. HCL, HashiCorp Declarative Language. So this HashiCorp Declarative Language is based upon the JSON format with keys and value pair. We never save that file as JSON. All your Terraform script file should be saved as TF. TF denotes Terraform. It is an extension for Terraform script file, and it is based upon your HashiCorp declarative language. Because Terraform is a product of HashiCorp. They are the owner of this product. So it is their own declarative script used to create a Terraform. And it is also declarative. It means it's very easy to code and manage. As like your YAML scripting, you can write it. It's very easy. And also, as part of the working process, you'll be learning about Terraform providers. Okay, I'll show you all those things one after the other. So now, what is the purpose of Terraform and how it is different from Ansible or any other things? So I think in the last session or previously we discussed about CloudFormation template. CloudFormation, or no, sorry, not for you people, right? Maybe in the next module, we'll be learning about CloudFormation. So Terraform and CloudFormation, you can able to compare. Using Terraform, you can able to prepare the target servers, resources, IT resources in any cloud platform. It is applicable to your AWS, Azure, or Google, or any on-premises servers. But this CloudFormation is meant only for your AWS resources. Okay. And this CloudFormation script can be written using YAML or JSON files. And it's very easy, very, very easy to create your CloudFormation templates. All right, so let me show you some more information here. Listen carefully. So if you want to work in Terraform, right, this is a basic architecture workflow for Terraform. Listen carefully. It all starts from the practitioner. Practitioner means the IT infrastructure management team who are responsible to create the infrastructure. Got it? This infrastructure management team, right? IT help desk or IT support team, they are available in their infrastructure for many years. Even DevOps, DevSecOps, and we talk about IAC tools. All these things are, recently we were using. But before these terms and DevOps comes into picture, these guys are there in the system. They know in and out of their project, their infrastructure. Got it? And what they do, they write some in-house scripts like shell scripts to manage infrastructure, but the shell script is having some difficulties. It is not that easy to write and manage for a longer term. So to eliminate all the complexities of writing or managed shell script, we recommend them to use IAC tool like Terraform. So once we introduce IAC tool, the practitioner, that is your IT team or support team, will be preparing the code like a Terraform script. The Terraform script will identify all the resources that you want to create. Once the script is ready, we will subject it to plan. Plan is just a process of previewing your script. What all the scripts you written, whether it is valid or not, including the syntax check, the resource definition check, the parameters check, and also it compares with the real-time environment and check whether the resource is feasible to create everything. Once the plan is successful, once the script is valid, then we'll be applying the changes. So when you say Terraform apply, that is where the actual resource definition will happen. It just creates it actually. And this apply can be done on any target platform. It can be a Kubernetes cluster or AWS, Google Cloud Platform, or Microsoft Azure, or any VMware resources, right? That matters. And also the script, whatever you prepare, it can be stored in a separate storage server, or it can be a GitHub repository to version control the scripts. Correct. So I was talking about the users, right? IT support team who write their own script. Let's say for an example, consider if you want to create a resource, a VM or EC2 instance, what you'll do? You'll directly get into your AWS console, click on launch instance, and then manage your parameters to create the resource. This is one scenario. But consider you have to create around 200 servers, for example. And each and every server has its own unique parameters. Few servers will be needing T3 medium, few will be needing T3 large, right? Few might be using Amazon Linux, few might be using Ubuntu, few might be using Mac or Windows, few will be using its own storage security group and storage. Like this, there'll be a lot of unique parameters to be defined. So if that is the case, we cannot use this AWS console to manually launch this 200 servers, correct? Correct. It is a time consuming process, no? If you do it like this,
Yeah.
if you're listening, then how your traditional infrastructure management team manages all these things means they write their own in-house script. They rely on the shell script. Even today, most of the organizations, they are using their own shell scripts to manage it. Correct. And writing a shell script means they're just going to invoke or use this AWS CLI in their shell script. Like you can see, EC2 hyphen instance a variable, we are just using this parameters, right? So using AWS CLI commands, we can able to prepare the shell script and run the shell script on the target environment. So now if you can see here, this entire script is responsible to launch a node. To launch a node, what are the parameters needed? We are just passing those parameters here, nothing else. See your instance ID, instance type, AMID, all those stuff. Based on all these parameters creates it. But the main challenge here is this shell script needs a lot of validations. It's not having that much intelligence to take care of the resource provisioning automatically. If I submit this shell script, what if that EC2 instance is already available there? The EC2 instance, whatever I prepared, if it is already available, what will happen? What happens? Any guess? It will create a conflict, right? Because the IP address, whatever, and everything is going to create a conflict there. So we have to properly maintain the validation at each and every level before you launch or create a instance using a script. First, you have to check whether this server is available or not. If it is not available, then only you can go and create. Like this, a lot of intermediate validation has to be performed, and that is why it is complex. And also the human resource. Tomorrow, if any new person takes the responsibility, he has to be very much expert in scripting to manage all those things. So to simplify all these things, right, we just introduce a concept called IAC tool. So what are all things people were used to do with this huge script? We can simplify everything, and just with few parameters, we can able to achieve it. That's it. Just the entire script can be completed just with a set of parameters. That's all. So here using Terraform, you just identify the type of resource and the parameters required to execute. That's all. It will create. If the resource is already available, it won't create anything. Otherwise, it will create a new one. Like that, Terraform can able to take care of the resource provisioning. Same thing if you want to compare it with your CloudFormation, this is a script. This is an example for your CloudFormation template. Tomorrow, while working on your AWS model, I'll show you this with a demo. But here, this is something based upon your comparison. Both CloudFormation and Terraform are going to use the declarative scripts. Here, it can be a JSON file format or YAML file format, but here it is a TF file using HCL language. So what are all the parameters? Here, the resource identification, amazon.aws.ec2. This is the resource type. But here it is identified AWS underscore instance. Apart from that, what are all the parameters needed? Everything can assign one by one. Simple. Right. So first and foremost thing is we have to prepare the script. Once script is ready, then you can able to execute the script using your Terraform commands. Right. So like this, what are all the various IaaS tools available in market? Any guess? We talked about CloudFormation, Ansible, Terraform. Like this, what are all the other IaaS tools available in market? Did you get a chance to explore it? guys?
No idea.
Is Puppet one? Puppet.
Yes. So there are various IS tools available market, but whatever it is, it's all categorized in these three factors. One is your configuration management, server templating, and provisioning. Okay. We have a lot of things like Terraform, HashiCorp Packer, Vagrant, SaltStack, Puppet, Chef, Docker. Even Docker also considers IAC tool. Okay. But it is meant for server templating. So in general, all these IAC tools are categorized as configuration management tool, server templating or provisioning tool. So under configuration management only, we have our Ansible, Puppet and all. Under server templating, we have Docker, HashiCorp, Packers and Vagrant. And provisioning tool means it can be a Terraform or your CloudFormation. Got it? Now, how Terraform works? For which platform it works means using Terraform, you can able to work in any target platform. It can be used to provision resources in your on-premises servers, your VMware, or any major cloud service providers. And how Terraform works means, as I said, it is not meant for one particular target platform. Your AWS, Azure, everything can be created with the help of a Terraform. How it works means Terraform uses a 5 important principle, working principle. So that's what I was mentioning here. Terraform working process. So first point here is identify the scope. I am going to give you a shortcut, okay? If you want to practice and work in Terraform, if you follow this approach, you can use Terraform in any platform. Got it? Any target environment. So first thing is identifying this scope. Identify scope means your environment. Whether you're going to work on your AWS or Azure or your Google Cloud platform, where you are going to use Terraform. Using Terraform, what type of resource you're going to provision, whether you're going to provision AWS resource or Azure. Like that, first you have to identify the scope. Got it? Once you identify the scope, then only you can able to write the Terraform script. Because the Terraform script is going to use some resources, resource type and resource name. Let's say if I want to create a virtual machine in AWS, how can I refer the virtual machine in AWS?
EC2.
EC2 instance. I can't use this term in my Azure, right? In Azure, there is no term called EC2 instance. In Azure, we simply call it as a virtual machine. That's all. There's nothing like Azure instance or nothing like that. Just virtual machine. So depends upon your target environment only, your script will be composed. So if you're using AWS means your script should have all the keywords related to AWS resources. Got it? Once the script is ready, the next thing is we have to initialize. Provider. Initializing the Terraform provider by using Terraform init. So what is the purpose of initializing the provider? Means provider is a kind of agent. To be installed. Local machine to provision the target resources. So each and every target environment has its own unique Terraform provider. Like if you want to work in AWS, we have AWS provider, Terraform provider. Similarly, we have something called Azure Terraform provider. Like this, for each and every cloud target environment, Terraform has its own providers. And these providers has to be installed in the local project, you can say, or machine to provision the target resources. And once it is initialized, the next thing is we have to perform Terraform plan. So this Terraform plan is something used to preview the Terraform scripts. It is just to preview your Terraform script. It checks for the errors, compatibilities, feasibilities, and also it compares your current configuration with your real-time configuration and get you the summary of your resources which you want to create. If there's any errors, it won't allow you to proceed further. And the next and last thing is you need to perform Terraform apply. Right. So this Terraform apply means it is just to implement the changes. What are all the scripts you have created here? Preview will just preview the changes. If it is okay, if it is successfully previewed, then you can able to implement it. So Terraform apply will actually implement the changes in target environment. Right. With this, we can able to ensure that the resources created. So these are the 5 important working process. Do not forget this because in real-time environment, whatever the target environment it is, Terraform uses this 5 steps to implement. Any question? Any question here? Demo we
No.
can see tomorrow. Okay, I'm not going to show you any demo on Terraform today because it includes a lot of installation process and all. But today at least we'll finalize the prerequisites for the installation and all. But the actual installation demo I'll show you in the next session.
Loksai, hello.
Yeah.
So if we want to, run multiple instances, we use this a Terraform script, right?
Multiple instances means
Like in the AWS or Azure.
it's not like that actually.
Oh.
It is not to run multiple instances. It is used to provision. Like if you want to create your EC2 instance, you are using AWS console, right?
Right.
Similarly, you can use a Terraform. Terraform is an alternate way to create your AWS resources. And Terraform is not just for AWS. Using Terraform, we can able to create AWS, Azure, or any target resources. It is a provisioning tool.
Okay.
Get your point?
Yeah.
So it's just to provision multiple VMs in the different cloud platforms. That's it.
Not just VM, any resource. It is used to provision the IT resource. I said provision means creation. It is used to provision or create IT resources. Correct. It can be anything. Like consider you want to create a EC2 instance. To create a EC2 instance, what you need? What are things you create? You need a VPC, subnet, internet gateways, route table associations, network gateway, internet gateway. A lot of things are there, right? So all these resources can be created with the help of a Terraform.
Okay.
I'll show you, okay, in the upcoming session tomorrow, I'll show you a demo of how you can able to prepare all those resources using Terraform. Okay, so now we'll talk about Terraform provider, that is your Terraform registry. So Terraform registry is something used to manage all these things. Okay, so there is an official page. I'll show you. Oh, it's all understandable, all right? What are the things we are speaking here? Terms. Hmm. Okay. So this is the official page. If you want, I can put this in your class notes itself. Where's it? Installation. Anyways, tomorrow I'll show you the installation process. I'll show you how to install the things step by step. But before that, let's understand about this Terraform registry. Mm, yeah, listen, please. So this document will give you a complete picture about your Terraform installation process. Terraform can be installed in any platform, like it can be installed on Windows machine, Linux, or Mac. If you want to install it on your Linux machine, just with depends upon distribution. Like if it is Ubuntu means you can use apt. CentOS actually can use yum package manager. Like this, using the package manager, you can able to quickly install Terraform on your Linux machines. But if you want to install it on Windows machine, usually in Windows machine, we use Windows installer, right? It is a package manager for Windows machine. But using Windows installer, you cannot install this package. For this, you need a special package manager called Chocolatey. So this Chocolatey is a free and open source package management system for Windows machine. Through this package manager, you can able to install Terraform package on your Windows machine. Or if you're a Mac user, you can open your Mac terminal and use Homebrew package manager to install Terraform. And if you're not interested to use any of this package manager, like I'm not interested to install this chocolate in my Windows machine, means you can go with a manual installation. Manual installation means you can download the package, extract, and use it. That's all. Got it. I'll talk about this installation procedures in tomorrow's session. But for today's session, there is a very important thing called registry. So if you go to this page itself, there is something called registry here. Can you see this link? If you click on the registry, it will take you to your Terraform registry page, and just click on the Terraform providers here, browse providers. So you can able to see the complete list of providers from Terraform. Even the slide, you must have noticed these things. What are things I'm showing through my slide, right? The slide is completely based upon this official page only. I take a snapshot from here. I take some commands from here for training. So once you get into this page here, you can able to choose your provider. See, it is a huge list of resources. So if you want to work in AWS, just go to this AWS registry. And you can see just 4 days ago, they have introduced a new version of AWS provider. Similarly, let's check for Azure. See, they also introduced 4 days ago. Like this, no Terraform, these guys, they have a very frequent update. Even after 2-3 days, if you see this, you can find a new version. So very frequently they implement new changes in their services. So it is always recommended to get into this official page and capture the latest version of your Terraform registry and use it for your provisioning. Correct? Maybe tomorrow, once we start with our Azure, you'll be seeing how to use this Azure Resource Manager. That is the provider for Azure resources. For AWS, just AWS. Now, how you can able to work on this registry means Terraform provides a very good set of documentations. So from this page, choose a provider, and from that provider's landing page, there is an option called documentations. Just click on this documentation. You can able to see the huge list of scripts. I told you, right, the HashiCorp declarative language. So this is how we prepare the script actually. And writing a Terraform script, it is always recommended to follow the official documentation. Do not try to create your own script because these guys are doing a very frequent changes in their service. Like you can see just 4 days ago, they have released one new version, right? So if you want to utilize the latest changes or latest version of your script, get into your page and try to utilize the script whatever provided here. So on the left side, you can able to navigate. So these are all the huge list of resources that can be provisioned using Terraform, not just EC2 instance. You can see here, right? All these things are AWS resources. You can able to create all these resources using Terraform. So here we have something called Elastic Container Service related things and Elastic Kubernetes related resources, right? Beanstack, containers, right? Like this, what are all these services you are seeing here on your AWS platform? There's a service catalog, right? You can see. So through Terraform, you can able to create all these resources. Without using console, you can able to create it. Got it? Similarly, if you explore your Azure registry, you have a documentation. And here, left side, you can able to see some resources related to Azure. All your Azure resources can be created. Let's say if you want, you can search for virtual machine. Can you see this? Azure RM virtual machine. So this is a small script that is to create your virtual machine. Here it is. For AWS, it is easy to instance. They just use the term resource. That's all. See? Easy to instance. Yeah, you can create a AWS instance, your key pair, everything. If you click on this AWS instance, you can see the script to create it. Just a very small script. You can able to create it. So like this, depends upon your requirement. You can able to prepare the resource definition and implement it. But it requires a lot of resource level knowledge. For example, if you want to use any resource provisioning tool, whether it is a Terraform or a CloudFormation or what else, Azure Resource Manager, whatever the resource provisioning tool you're going to use, you should have the detailed understanding about the resource. For example, if you want to create a EC2 instance, right? So far, you must have created many resources, right? VMs on your cloud platform. So to create a EC2 instance, what are the parameters you used? Do you remember? What are all the parameters you used to create EC2 instance?
Tags, images, key pairs.
So like this, what are all the resources you have? The entire service catalog you can see. I have a huge list of resources. It can be related to my compute service, container service, database, or customer enablement, right? Each and every category has its own list of services. So through your Terraform, if you want to create any such resources, you should have a detailed understanding about the service. Based upon that only you can pass some parameters, correct? The parameters what you're seeing here, it is specific to that particular resource. So there is a extensive practice and knowledge about the resources required. That is the reason we have a separate role called solutions architect role. They are the architects who will be having the end-to-end cloud knowledge. If you are from DevOps background, you will not have such resource exposure to the resources. But architect's role is to manage and work with the resources every day, right? So, and also the infra team who is managing database resources. Easy? Any question? I'm just giving you a quick overview of all these things, okay? Tomorrow we'll start with the proper installation because it requires some steps to be followed. A lot of things are there. We are not just going to install Terraform. We also need Visual Studio Code. Do you guys have Visual Studio Code in local machine?
Yes.
Yes.
And then you need to have your Visual Studio Code. So what is the need for Visual Studio Code means? It is used to create Terraform projects and Terraform scripts. Okay, it is promptly meant for preparing your project and script. That's it. And apart from this, you need to be very clear about your target resources. Okay, that matters. Any question, please let me know. And we'll go with the manual installation. Okay, I'm not interested to install Chocolatey and does not recommend also in real time. Okay, honestly, don't dump your local machine with additional plugins and all. You can use your manual installation procedure to install and configure it. Okay, any idea why I prefer to use this one, local Windows machine? Any guess? Any guess why we need this? Why we try to install a local Windows machine? Why can't we have your resource? Let's say I have installed my Ansible Jenkins in this AWS platform, right? Like this, if I want, I can launch one VM and install Terraform there, right? Why I want to install local machine? Any guess?
I think we don't know where we are deploying that script.
Means
Means means whatever we are performing the project and script, so where we are deploying the AWS, Azure, and then GCP like this.
it's not like that actually. My requirement is to create a resource in a cloud platform, correct? I have AWS cloud platform and I want to create a virtual machine in AWS cloud using Terraform. So it is always a best practice to have this Terraform installed in their individual machine. From my machine, I can able to create a cloud resource using Terraform. That should be the case. For installing Terraform itself, if you're launching a node in AWS, then there is no relevance there, right? Are you able to understand the scenario? If I want to launch, if I want to install Terraform, I have to manually launch one node. After manually launching a node, you can install Terraform, and then using Terraform, if you're launching another node, means there is no point there. So any user part of admin team, IT infrastructure management team, they'll be having such IAC tools installed in the local machine. In their local workstations, they have it, so that they can able to quickly access through those resources and provision it. Easy. Or if you want to share it with multiple users, you can launch one node, install Terraform, and share that resource, share that node with other users in the team, so that everyone can able to perform some parallel changes. Easy. Hope you are clear with this process. Guys, are you listening?
Yes, yes, sir.
Yeah.
It's clear.
All right then. So if you guys have any question, please let me know. I'll stop with this for now. I'm not going to continue with this installation process. It's a bit lengthy process. So tomorrow, as soon as you log in, I'll start from the installation and I'll let you know how to create some Terraform projects and start provisioning the resources. Easy? Any question, please? Yeah, I'll be placing this document here in the training document. Let me create a new folder for Terraform. Okay, this is for Terraform. And this is for your Ansible.
Looks like Prometheus and Grafana are the monitoring tools.
Yeah.
And similarly, we have Datadog and Site 24/7 as well.
Yeah.
Okay.
And here in the Ansible folder, there is a file called Ansible installation in practice. So let me edit this file and add all the concepts related to handlers and other stuff today. So hope you are clear with the concepts, right, guys? Any issues you have, please let me know. Are you guys able to understand the importance of Terraform? Tomorrow we'll just reiterate everything. Okay, I'll explain again. And I mean, during installation, definitely I have to touch base on all these things. Installation will be a crucial process there. I'll show you how to install and set up your environment in your local machine. And along with that, we'll see all the 5 processes of Terraform, starting from resource identification, scope identification, and then writing a script, Terraform init, plan, and apply. We'll see one by one in detail. Got it?
And if in case we have to install this Terraform in the real-time environment, we have to follow the same process.
Yeah, this is what we do in real-time environment. Yep.
Okay.
Okay. Any questions, guys? Yeah, I'm done for today's session. I just update all the documents here. If you have any question, let me know. We'll talk about it. Otherwise, we can connect tomorrow. All good?
Yes, sir.
All right, so thank you.
Thank you.
Yeah, thank you all. Thank you. Bye.